Dear students, welcome to my classroom. In the previous part of the chapter quadratic equation, we learned what is the definition of quadratic equation and what is the standard form of quadratic equation. And also we learned that how to check that whether the given equation is quadratic equation or not. And also we solved some problems in exercise 5.1. And in this class we are going to learn how to form the quadratic equation as well as how to solve the quadratic equation in factorization method. Okay, so let us solve remaining problems in exercise 5.1, and in exercise 5.1 we solved the first bit and we have to solve the second bit now. Represent the following situations in the form of quadratic equations. So the first one is the area of a rectangular plot is 528 meters square. The length of the plot is 1 meter more than twice its breadth. We need to find the length and breadth of the plot. So let's solve this question. So in this question, it is given that the area of a rectangular plot is 528 meters square, and also given that the length of the plot is 1 meter more than twice its breadth. So using these hints, we have to form the quadratic equation, which helps us to find the length and breadth of the plot. Okay, so let us draw the rectangle. So in this rectangle, it is given that the length of the plot is 1 meter more than twice its breadth. That is, the length is depend upon the measurement of breadth. So let us take the breadth of the rectangular plot first. So let us assume that the breadth of the rectangular plot be x meters. Okay, here the area of the plot is 528 meters square, and we taken the length breadth of the plot as x meters. Now it is given that the length is 1 meter more than twice its breadth. So let us write the length in terms of its breadth. So here it is given that length is 1 meter more than twice its breadth. What is twice its breadth? As the breadth is x meters, then twice the breadth is 2x, and as it is 1 more than twice its breadth, we can write the length as 2x plus 1, because length is 1 meter more than plus 1 to whom plus 1, twice its breadth, that is 2x. So its length is 2x plus 1 meter. Okay, so now let's write, let the breadth of the rectangular plot be x meter, then length of the rectangular plot is 2x plus 1 meter, and according to the problem, what is given? Area of the rectangular plot is 528 meters square. Okay, we know that area of the rectangle is length into breadth, so that we can write length into breadth is equal to 528. What is here length? Length is 2x plus 1 and the breadth is x meters. So length into breadth, that is 2x plus 1 into x, is equal to 528 meters square. That is area of the rectangular plot is 528 meters square, and the area of rectangle is length into breadth, that is 2x plus 1 into x, is equal to 528. Now we can multiply 2x plus 1 with x, that is 2x into x is 2x square plus 1 into x is equal to 528, that is 2x square plus x is equal to 528, and by transposing the 528 to left side, we get 2x square plus x minus 528 is equal to 0. This is our required quadratic equation. So let's go for second one. The product of two consecutive positive integers is 306. we need to find the integers. So in this case we have to form the quadratic equation which helps us in finding the given integers. Okay, so we know that consecutive positive integers are of the form x and x plus 1 because the second integer is one more than its previous integer. Okay, so in that way we can take the consecutive positive integers be x and x plus 1. And now according to the problem, the product of these two consecutive integers is 306. That is x into x plus 1, that is product of the integers, is equal to 306. That is x into x plus 1 equal to 306. So from this we can write that x into x is x square plus x into 1 is x is equal to 306. That is x square plus x equal to 306. And from this we can write x square plus x minus 306 equal to 0, which is our required quadratic equation. Okay. And next go for third one. Rohan's mother is 26 years older than him. The product of their ages after 3 years will be 360 years. We need to find Rohan's present age. Okay, students, here there are two persons. Who are they? Rohan and his mother. So these are the quantities that we are dealing with now. Rohan's age and mother's age. So at present, let the Rohan's age be x years. So there are two situations, at present and after 3 years. And let the Rohan's age at present be x years. And according to the problem, what is his mother's age? Rohan's mother is 26 years older than Rohan. That is, as the Rohan's age is x years, then his mother's age is 26 years more than Rohan's age. That is x plus 26 years. And what will be the Rohan's age after 3 years? Then after 3 years, Rohan's age will become x plus 3 years. And mother's age will become x plus 26 plus 3. That is x plus 29 years. Okay. So now let us write that let the Rohan's age at present be x years. Then his mother's age at present is x plus 26 years. And after 3 years, age of Rohan would be x plus 3 years. And Rohan's mother age would be x plus 29 years. And now, according to the problem, what is given? The product of their ages after 3 years. So what are the ages after 3 years? X plus 3 and x plus 29. And it is given that the product of their ages is 360. That is x plus 3 into x plus 29 is equal to 360. And by multiplying x plus 3 and x plus 29, what we get? X into x, x square, plus x into 29 is 29x, plus 3 into x is plus 3x, plus into plus 3 into 29 is 87. That is x square plus 29x plus 3x plus 87 is equal to 360. And from this we can write x square, 29x plus 3x can be simplified as 32x. So x square plus 32x plus 87 minus 360 equal to 0. And from that we can write x square plus 32x minus 273 equal to 0. This is our required quadratic equation. Okay. So let's go for fourth one. A train travels a distance of 480 kilometers at a uniform speed. If the speed had been 8 kilometers per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. And students, we know that the speed is inversely proportional to time. If the speed increases, then time will be decreases. And if speed decreases, then the time taken will be increases. Isn't it? So in this problem, it's given that train to be travel a distance of 480 kilometers. If the speed had been 8 kilometers per hour less, then the train would take 3 hours more to cover the same distance. So we need to find the speed of the train, and for this situation we have to form the quadratic equation. Okay, so here we have three quantities: distance, speed and time. And in first case, the distance to be traveled by train is 480 kilometers, and we don't know the speed of the train. So let x be the x kilometer per hour be the speed of the train. Then we know that time is equal to distance by speed. Then time taken to travel 480 kilometers by train is distance by speed, that is 480 by x hours. And in case 2 also train to be travel 480 kilometers only. And in this case, speed had been 8 kilometer per hour less. That is, the speed is decreased by 8 kmph less. So then the speed is x minus 8 kilometer per hour. And in this case also time is equal to distance by speed and is equal to 480 by x minus 8 hours. And we know that in these two time cases, in first case we have time 480 by x, and in second case time has 480 by x minus 8 hours. In these two quantities, in which denominator is less? In second case, the denominator x minus 8 is lesser than the denominator in first case, that is x. So the value 480 by x minus 8 is more than 480 by x. Okay, and the difference of these timings is equal to 3 hours. So now let us write that the distance to be traveled by train is 480 kilometers. Let the speed of the train be x kilometer per hour. Then the time taken for train to travel the distance is distance by speed, that is 480 by x hours. And if the speed had been 8 km per hour less, then what will be happen? The speed of the train would be 480 by x minus, speed of train would be x minus 8 km per hour, because the speed is reducing by 8 km per hour less. So the speed of train would be x minus 8 km per hour, and the time taken will be 480 by x minus 8 hours. And according to the problem, the difference of these timings is 3 hours. That is 480 by x minus 8 minus 480 by x is equal to 3. So let us simplify this equation. So in this equation we can take 480 common. So that is, we can write 480 into 1 by x minus 8 minus 1 by x is equal to 3. And we can simplify the fractions in the bracket. So we can take x minus 8 into x as LCM. Then it become 480 into x minus half x minus 8 by x into x minus 8 is equal to 3. And the numerator is equal to x minus x plus 8. That is, x minus x will be cancelled and 8 will be remain. And in denominator, x into x minus 8 is x into x square, plus x into minus 8 is minus 8x. So now let us transform x square minus 8x to right side and 3 to left side. That is, we get 480 into 80 by 3 is equal to x square minus 8x. And we can divide 480 by 3 in 360. So 3 160s are 480. That is, 160 into 8 will be remain. So x square minus 8x equal to 160 into 80, 160 into 8. So we get x square minus 8x equal to 1280. And let us transpose the term 1280 to left side. So we get x square minus 8x minus 1280 equal to 0. So this is our required quadratic equation. Okay students, that's the end of exercise 5.1, and let's go for the next topic. And the topic is solution of a quadratic equation by factorization. That is how to solve a quadratic equation in factorization method. So before going to that, what is the solution of a quadratic equation? Let we know. Okay. So consider the quadratic equation x square minus 5x plus 6 equal to 0. If you replace x by 1, then the value of LHS, that is the value of polynomial x square minus 5x plus 6 at x equal to 1 is 1 square minus 5 into 1 plus 6, and this one equal to 1 minus 5 plus 6, which is equal to 2, and which is not equal to the RHS of the equation. That is, here x equal to 1 is not satisfies the quadratic equation. And if you replace x by 2, let's see what we get in left hand side. In left hand side, we get 2 square minus 5 into 2 plus 6. That is 4 minus 10 plus 6, which is equal to 0 and which is equal to RHS. That is, by substituting x equal to 2, the equation is satisfying. So since 2 satisfies the equation, we say that 2 is a root of the quadratic equation x square minus 5x plus 6 equal to 0. And also we can say that x equal to 2 is a solution of the quadratic equation x square minus 5x plus 6 equal to 0. The value 2 is said to be root of the equation, and x equal to 2 is said to be a solution of the quadratic equation. Okay. So in general, a real number alpha is called a root of the quadratic equation ax square plus bx plus c equal to 0 if a alpha square plus b alpha plus c equal to 0. That is, if we substitute alpha in place of x and the equation will be satisfied, then alpha is said to be the root of the quadratic equation. And also we say that x equal to alpha is a solution of the quadratic equation, or alpha satisfies the quadratic equation. Okay, students. And in previous chapter polynomials, we learned that the zeros of the quadratic polynomial ax square plus bx plus c has at most 2 zeros, and the zeros of the quadratic polynomial ax square plus bx plus c and the roots of ax square plus bx plus c equal to 0 are the same. So we learned how to find the zeros of the quadratic polynomial of the form ax square plus bx plus c, and here we have to notice that the zeros of the quadratic polynomial ax square plus bx plus c and the roots of ax square plus bx plus c equal to 0 are same. And we know that a quadratic polynomial ax square plus bx plus c have at most 2 zeros. So any quadratic equation can have at most 2 roots, because just now we have learned that the zeros of the polynomial ax square plus bx plus c and the roots of ax square plus bx plus c equal to 0 are the same. So that as the polynomial ax square plus bx plus c have at most 2 zeros, then the quadratic equation ax square plus bx plus c will have at most 2 roots. Okay, students. Now consider the quadratic equation 6x square minus x minus 2 equal to 0. Now let us discuss how to solve the quadratic equation by factorization method. So here, by comparing this equation with standard form, a is equal to 6. What is a here? Coefficient of x square is 6, and what is b? The coefficient of x is minus 1, and c is the constant, which is equal to minus 2. And we have to find two numbers p and q such that p plus q equal to b, that is equal to minus 1, and p into q is equal to a into c, that is 6 into minus 2 is equal to minus 2. To solve the given quadratic equation in factorization method, we need to find two numbers p and q such that p plus q is equal to b and p into q equal to a into c. So now let us factorize the value of a into c, that is 12. 12 can be written as factors of the form 1 into 2 or 2 into 6 or 3 into 4 or again 4 into 3, 6 into 2 and 12 into 1. So in this way 12 can be factorized either 1 into 2 or 12 into 1, at either 2 into 6 or 6 into 2, either 3 into 4 or 4 into 3. Now observe these three cases. In first case 12 is factorized as 1 and 12, 1 into 12. So using these two values we can't get the value of b such that either p plus q equal to b or p minus q equal to b. That is neither 1 plus 12 equal to 1 or 1 minus 12 equal to 1. And similarly neither 2 plus 6 equal to minus 1, 2 minus 6 equal to minus 1. But we can notice that plus 3 minus 4 is equal to minus 1. So the values of p and q satisfying that p into q equal to minus 12 are 1 into minus 12, 1 comma minus 12, minus 1 comma 12, 2 comma minus 6, minus 2 comma 6, 3 comma minus 4, minus 3 comma 4. All these values are satisfying p and q equal to minus 12, but only one value, only one pair of values is satisfying p plus q equal to minus 1, and that pair is minus 3 comma minus 4. Okay, so among these pairs we have only one pair of values p and q such that p plus q equal to minus 1. That values are p equal to 3 and q equal to minus 4, isn't it? So 3 plus minus 4 is minus 1, 3 into minus 4 is minus 12, which is equal to p and q. Okay, now the middle term, the quadratic equation, that is minus x, can be split as plus 3x minus 4x, because just now we noticed that minus 1 is equal to plus 3 minus 4. So we are splitting minus x as plus 3x and minus 4x. Now let us see how to solve the equation. So now take the equation 6x square minus x minus 2, and this minus x can be split as plus 3x minus 4x. And now among first two terms we can take 3x common, and among second two terms we can take minus 2 common. So if you take 3x common in first two terms, what we get? 3x into 2x plus 1. And if you take minus 2 common in after two terms, we get minus 2 into 2x plus 1 is equal to 0. And in both these two terms, in both the terms we have 2x plus 1. So we can take 2x plus 1 common also. So that is, we can write 2x plus 1 into 3x minus 2 is equal to 0. And as the product of these two expressions is equal to 0, then either of this must be equal to 0. That is either 2x plus 1 equal to 0 or 3x minus 2 equal to 0. And from this we get 2x equal to minus 1 or 3x equal to 2. And x equal to minus 1 by 2 or x equal to 2 by 3. Therefore, the roots of the quadratic equation 6x square minus x minus 2 equal to 0 are minus 1 by 2 and 2 by 3. In this way, we can find the roots of a quadratic equation by factorizing it into two linear factors and equating each factor to 0. Okay, students. So let us check whether these two values are roots or not by substituting these values in the equation. Now let us check whether the values we got, that is minus 1 by 2 and 2 by 3, are the roots of this equation or not. That is, whether these values will satisfy the equation 6x square minus x minus 2 equal to 0 or not. So let us substitute x equal to minus 1 by 2 on left hand side. So the value we get is 6 into minus 1 by 2 whole square minus of minus 1 by 2 minus 2. And minus 1 by 2 whole square is 1 by 4. And minus of minus 1 by 2 is plus 1 by 2 minus 2. That is, we get 6 into 1 by 4 plus 1 by 2 minus 2. And we can divide both 6 and 4 by 2. That is 2 3s and 2 2s. So we get 3 by 2 plus 1 by 2 minus 2. So 3 by 2 plus 1 by 2 is 4 by 2. 4 by 2 is 2. And we have minus 2 also. 2 minus 2 is equal to 0. That is minus 1 by 2, 1 by 2 satisfies the equation we have taken. And let us check whether 2 by 3 is, will satisfy the equation or not. So substitute 2 by 3 in place of x. That is 6 into 2 by 3 whole square minus 2 by 3 minus 2. And 2 by 3 whole square is 4 by 9. So we can write it as 6 into 4 by 9 minus 2 by 3 minus 2. And in 6 into 4 by 9, we can divide both 6 and 9 by 3. That is 3 2s are 3 3s are. Now the expression becomes 2 into 4 by 3. That is 8 by 3 minus 2 by 3 minus 2. And we know that 8 by 3 minus 2 by 3 is 6 by 3, which is equal to 2. And 2 minus 2 is equal to 0. So in this way, the values we got are satisfying the equation 6x square minus x minus 2 equal 0. So that we can say that minus 1 by 2 and 2 by 3 are the roots of the equation. Okay, students, that's all for today. And in next class, we shall solve the problems in exercise 5.2, which are based on the solution of quadratic equation by factorization method. Until then, see you. Bye.